Take a look around. Everything you can see. The device you're on right now. Every star, planet, and galaxy. All of it is just a tiny 15% slice of the stuff that makes up our universe. So what about the other 85%? Well, it's a ghost. It's a substance that is everywhere, all around us, but it's completely invisible. It doesn't create light. It doesn't block light. It doesn't reflect light. And yet, if it weren't there, our universe would simply fall apart. Galaxies would fly apart. Stars would be flung into the void. We wouldn't be here. Scientists call it dark matter. And the hunt for this cosmic ghost is one of the greatest detective stories of all time. Our story kicks off almost a century ago, back in the 1930s, with a brilliant and famously grumpy Swiss-American astronomer named Fritz Zwicky. He was studying a huge group of galaxies called the Coma Cluster, when he noticed something off. The galaxies on the edge of the cluster were moving at unbelievable speeds, so fast that the gravity from all the visible stars and gas shouldn't have been strong enough to hold on to them. Based on what he could see, the whole cluster should have been tearing itself to shreds. But it wasn't. It was holding together just fine. So Zwicky did the math, and the result was staggering. For the cluster to stay intact, it needed about 400 times more mass than he could actually see. He figured the space between the galaxies must be packed with some kind of invisible stuff, which he called dunkel Materie, dark matter. It was an idea so bizarre, so out there, that for decades most scientists just ignored it. It was a neat ghost story, a weird little puzzle, but not a crisis. The piece didn't fit, so they just left it in the box. The mystery sat on a shelf until the 1970s, when an American astronomer named Vera Rubin dragged that ghost out of the history books and into the spotlight. Armed with a powerful new piece of tech, Rubin and her colleague Kent Ford started measuring the speeds of stars inside spiral galaxies, beginning with our next-door neighbor Andromeda. Now, basic physics says that stars on the far edges of a galaxy should move slower than stars near the center. Just like Pluto plods along while Mercury zips around the sun, but that's not what she found, not at all. Rubin discovered that the stars at the very edge of a galaxy were moving just as fast as the stars near the bright, crowded center. The rotation curves were weirdly flat. Think of it like a merry-go-round. The kids in the middle are moving slowly, but the kids on the edge are whipping around, hanging on for dear life. What Rubin saw was like finding that everyone on the ride, no matter where they were standing, was moving at the same crazy speed. The only way for that to happen is if a huge amount of invisible mass was spread all through the galaxy, acting like a gravitational seatbelt holding those outer stars in place. Her work showed that galaxies must have 5 to 10 times more dark matter than regular matter. Suddenly, this wasn't just a quirk in the Coma Cluster, it was everywhere. The clues just kept piling up. Astronomers saw how light from distant galaxies was being bent and warped as it passed by other massive clusters, an effect called gravitational lensing. The more the light is distorted, the more mass there is, and time again, the numbers were way off. The visible stuff wasn't nearly heavy enough to cause the lensing they were seeing. But the knockout punch came from a cosmic collision called the bullet cluster. This is actually two galaxy clusters that smashed through each other. With X-ray telescopes, you can see the hot gas from the normal matter. It slowed down in the crash and is now stuck in the middle, glowing pink in the images. But gravitational lensing shows that most of the mass, the dark matter, sailed right through the collision without even slowing down. This picture showing the visible matter separated from the invisible mass was the first direct proof that dark matter is real. Okay. So if 85% of all matter is this invisible stuff, the next question is, what is it? This is where the detective story turns into a phantom hunt, and physicists have a pretty wild police lineup. For a while, the top suspect was a particle called a WIMP, which stands for Weakly Interacting Massive Particle. The idea is that WIMPs are heavy, slow-moving particles left over from the Big Bang. They're weakly interacting because they pretty much ignore normal matter. Trillions of them could be flying through your body right this second and you wouldn't feel a thing. The theory goes that if two WIMPs ever did collide, they'd annihilate each other in a flash of gamma rays that we could potentially spot. But WIMPs aren't the only suspect. There's also the axion. Axions are thought to be incredibly light, maybe 1 trillion times lighter than an electron. The funny thing is, they were invented to solve a totally different problem in physics. But they just so happen to have all the right properties to be the ghost we're looking for. And the ideas get even weirder from there. Some scientists, like the late Stephen Hawking, suggested dark matter could be primordial black holes. Tiny black holes formed in the first seconds of the universe. Other theories even hint that it could be a sign of a mirror world, a hidden reality with its own particles and forces that only talks to our world through gravity. So how do you catch a particle whose main characteristic is that it's impossible to catch? You build the most sensitive traps on Earth, put them in the quietest places imaginable, and you wait. To pull this off, scientists have gone deep underground to hide from the noise of cosmic rays. A mile beneath South Dakota, in an old gold mine, is the LZ experiment. It's basically a giant 7-ton tank of super pure liquid xenon. The hope is that, out of the trillions of dark matter particles flying through it, just one will eventually score a direct hit on a xenon nucleus, creating a tiny flash of light that super-sensitive sensors can see. And as of late 2025, after more than a year of listening for that little ping, they have found precisely nothing. No WIMPs. And while that sounds like a failure, it's actually fantastic news. It tells us where not to look, ruling out a huge range of possibilities for what WIMPs could be. The hunt is getting trickier because of something called the neutrino fog. As these detectors get more sensitive, they start picking up signals from neutrinos from our own sun, which can look a lot like the WIMP signal they're trying to find. Meanwhile, other astronomers are looking up instead of down. In late 2025, a fascinating but totally unconfirmed claim popped up. A researcher sifting through data from NASA's Fermi Gamma Ray Space Telescope said they'd found a halo of gamma rays at the center of our Milky Way. The signal's energy looked a lot like what you'd expect from annihilating WIMPs. If other telescopes can confirm it, this could be it. But for now, everyone's being cautious. It could be the ghost, or it could just be another cosmic mirage. With the main suspects having such a great alibi, some scientists are asking a pretty radical question. What if we're wrong about everything? What if there is no ghost particle? What if our understanding of gravity itself is what's broken? This idea is called MOND, or Modified Newtonian Dynamics. First proposed in the 80s, MOND suggests that gravity doesn't always play by Newton's rules. At the incredibly tiny accelerations you find across the vastness of a galaxy, MOND says gravity actually gets a little bit stronger than we expect. This tweak neatly explains why galaxies spin too fast without needing any dark matter at all. But MOND has its own issues. It works great for single galaxies, but it really struggles to explain things like the bullet cluster, where the mass and the visible matter are clearly in two different places. Because of that, most physicists are still betting on dark matter, but MOND is a powerful reminder that the universe might be even stranger than we think. We started with a strange fact. Everything we've ever known or seen is just a tiny fraction of what's out there. 85% of the matter in our universe is missing. An invisible scaffold that our cosmos is built on. We've followed the clues from Fritz Zwicky's lonely insight to Vera Rubin's undeniable proof. We've gone a mile underground to the quietest places on Earth, where scientists are just listening, hoping to hear a single ghostly whisper. The hunt is still on, but what's at stake is everything. We now understand that without dark matter, the universe would be empty. Its gravity was the seed that allowed matter to clump together, to form the first stars and to build the magnificent galaxies we call home. Without dark matter, there'd be no Milky Way, no sun, and no us. The biggest mystery in the cosmos isn't in some far-off galaxy. It's passing through you right now, holding our world together. And finding it won't just fill in a blank on our map of the universe. It will change our understanding of reality itself.